session. We've seen about the 2 hours. That means what? Commutative as well as associative hours, right? Very simple. And now after the addition, after this one, we gotta go for this product. That means what? It's gonna be multiplication. That means you don't think about, see, we don't read about only the multiplication of vectors from this direction or from that direction or from top of the direction or from any direction to a magnet. If more number of pins are getting attracted, that's called what? A product. Product means what? 1 into 2 equal to 2. 1 into 4 equal to 4. 1 into 8 equal to 8. 1 into infinity equal to infinite. That means this is a magnet. I take a pin. That's gonna be very right. Please write about the girl. And this is a pin. To this magnet, the pin is getting attracted. Now it's attracted. This pin can able to share magnetic power to 1, 2, 3, 4, 5, 6 as much as it can. So now the magnetic power is getting multiplied from one pin to more number of pins. I got the point, right? One pin to more number of pins. That is called what? Product of vectors, because from wherever, from whichever direction it comes, the direction isn't the problem, but the vector that shows about the product of more number of incoming attracted things. Now we got the point, right? One pin to more number of pins. That means what? It's about the multiplication. That means it's called the product. So what I do, I will explain very clearly. Now I just gotta remember about this one. Now we've seen everything, is it right? Leave off everything. That's gonna be very simple. Now I see about this one. So the product is A is a magnet and dot B is a pin, and it's almost equal to, not exactly equal to, okay, almost equal to, I'm going to multiply IB because, for example, if I'm in a room and my friend also joining me, if we both are talking, means the person who's standing outside the room, they will hear both of our voice in a form of wave. Is it right? In a form of a wave. Is it right or not? And that's surely right. So what I tell you means my voice and my friend's voice both are same, both are coming from same, both are get product, because we both got the product. Is it right? So look at over here, I got a cos because my voice is going in a form of wave, right? Because in the magnet also, the magnet's effect around the circle or any such shapes, it may go in the form of wave, wave in the circle direction. If you take a pin inside the field, and in that field all this power of the magnet in the form of a wave. That's called what? Cos. And afterwards I'm going to write the theta. It may be of any angle. In this direction means this is the magnet, this is the field, okay? This magnet's action will be here, 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 here. Suppose if we have a pin here, this form an angle with the magnet with respect to the surface is some angle. That angle is called what? Theta. That theta is here. All are wave straight, wave in the form of a sinusoid. That's what we call cos wave. The cos wave is more important. And that's going to be a cos theta. This is about the product of any such two magnetic power, okay? And then afterwards, what I'm gonna do, we will see about the next one. That means I'm going to have A plus A. A itself getting added. I'm sorry. A dot A. That means, first of all, a magnet itself joining with another magnet. You know, is it right? If you have one magnet, if you take one more magnet, that both will get attracted, not by a pin. A magnet itself attracts another magnet, and that's is equal to A square. It replicates, or in other words, it's going to get increasing in the form of exponential. That's called replication. Okay, and now listen over here. So A is equal to, what's going to be A is equal to? It's going to be any root of A dot here. If you remove the root, it may be a plus or it may be a minus. Is it? No. It should be the form of plus. It's not a minus. For example, if you take a 4, square root of 4 means you can have plus or minus 2. Because minus to the whole square is equal to 4, plus to the whole square is equal to, but in the form of a magnet, you don't want to go for decreasing. What you go for only the increasing form, let's go what? Plus. Because magnets give the power and it will never lose its power. That is the one. Okay, do you understand me? A magnet will always deliver the power and that will be having the plus, and magnets will never lose the power. So there will be surely no minus available because you are having one product. You are not having minus one product. Okay, you got that right? And now I'm gonna go for these two laws for this product also. What are the two laws? A commutative law. Commutative law. A dot B equal to, if I have two magnets, will get attracted. Whatever side it may be, A is this side, B is this side. Suppose if I interchange, A is this side, B is this side, both will attract, right? Sure, they'll attract, right? That's sure. So B dot A, place is not a problem. And then afterwards, A dot B plus C, what's equal to, if I have two pins getting wounded, if I take the two pins near to the magnet will attract both them. First you go to the plus, okay? The magnet attracts the first pin also, the magnet will attract the second pin also. Both the pins the magnet will attract. I got the point, is it right? This is the one about the product. Just wait for about the next one.